Okay, so we're going to start not a new theme, so it's still going to be working on theme 2, which is probability. However, we're going to start on like part 2 of probability. So part 1 was our permutations and combinations and ordering objects. Now we're going to start on this idea of Bayesian statistics. Now, who in here has heard of Bayesian statistics before? Who in here has studied Bayesian statistics before? Has anybody done that? No? Okay, so it's going to be a new topic for most of you then. Now, before we move any further, I just want to draw your attention to this quote here. This is from Nate Silver, okay? And it says, it's hard to find anything that doesn't advocate a Bayesian approach. Now, as an introduction, Bayesian statistics is essentially the way, the mathematical way of thinking. Okay, so when you're looking at how people learn, how people think, it's using this idea which a guy called Thomas Bayes came up with. Okay, and it's basically a way of updating your beliefs based on new evidence. Okay, so let me sort of do a quick thought experiment with you. Okay, so let's imagine you wake up one morning feeling really ill, like you feel like absolute death. Okay, so you go along to the doctor. And the doctor kind of looks at you and thinks, I'm not quite sure what's wrong with you. It could be this, it could be that. I haven't really got a diagnosis for you. So what they do is they take some blood, okay, and they do a few tests for you. Now, this test, a couple of days later, for this really kind of horrible disease, come back positive. Now, this is a really horrible disease, like you really don't want it, okay? And it comes back as positive. Now, the thing is, you being a mathematician kind of look at this going, well, actually, I need some more evidence here. Okay, so you say, well, actually, how accurate is this test? Just because I test positive, how accurate is this test? And so the doctor tells you that this disease, really horrible disease, affects 0.1% of the population. So it affects 0.1% of the population. Okay, and also you want to know the accuracy of the test, and the doctor tells you that it's 95% accurate. Okay, so it's 95% accurate. Now, can I give you 30 seconds? And just think about this, okay? I want you to think about what is the probability that you actually have the disease, okay? Now, I notice some of you have got your notes open in front of you, so you kind of see the answer, okay? But just by sort of thinking about it for 30 seconds, okay, what's the probability that you actually have the disease? And I'm actually going to give you 4 options here. It can either be 100%, 95%, 9.5%, or 2%, okay? So give me 30 seconds. This is the information which I'm giving you. This is the evidence. What do you think? What's the probability that you actually have the disease given this evidence? Okay? So, here's what I want you to do. So hopefully you've got an idea in your head based on this evidence. I've only really given you 2 pieces of information. Number 1, it affects 0.1% of the population. Number 2, the test is 95% accurate. So can you all shut your eyes for me? Can you all shut your eyes? Okay? And what I want you to do is I want you to hold up the number of fingers that you think the answer is. So just a reminder, if you think it's 100%, you need to hold up 1 finger. If you think it's 95%, you need to hold up 2 fingers. If you think it's 9.5%, hold up 3 fingers. If you think it's 2%, hold up 4 fingers. So can I ask you to all vote now? So how many fingers? Okay, so put your fingers down then. Put your fingers down. Now you can open your eyes. Okay. So few people went for this one. They went for 95%. Okay. A few people went for 9.5%. And some people, and I think there was only like 1 or 2, went for 2%. So I would say this is probably the most popular one. Okay. Nobody went for 100%. Okay. Now, why shouldn't it be 100%? Why is it not 100%? So you're happy the test is only 95% accurate. So you're not going to be 100% likely that you have the disease. Just because it comes back positive, the test is 95% accurate. It's not 100% accurate. So therefore, it's not going to be 100% certain you have the disease. Okay, so it can't be 100%, right? Now, a lot of people went for 95%. Why do they go for 95%? Anybody want to suggest why you went for 95%? Absolutely. Test is 95% accurate. And actually, when I first looked at this problem, I thought it was 95% as well, okay? Now, I'll give you a spoiler. It's not 95%. So just because the test is 95% accurate, that does not mean that you have a 95% chance that you've got the disease, okay? So it's not 95%. Now, I can see why some people went for 9.5% because they said, well, 0.1 times 95, yeah? That's 9.5%, okay? So you can kind of see those two things together, kind of try and make 9.5%. It doesn't quite, but you can see where it comes from. The actual answer is 2%. Okay, so the actual answer is 2%. Now, does that surprise anybody? I know some people went for it, but does that surprise anybody? Yeah, that seems weird, right? Because you've gone to the doctor, you've taken a test, it comes back positive. Like, sure, the test is 95% accurate, but there's still only a 2% chance, even though the test has come back positive, that you actually have the disease. That's really low.
That means you got the disease.
Exactly. There's only a 2% chance. Even though the test has come back positive, there's only a 2% chance that you actually have this disease, right? That's pretty weird, isn't it? That's a really low probability, really low probability. Now, let me try and illustrate why. So I've given you these two pieces of information. I've told you that the disease affects 0.1% of the population. And I've also told you that the test is 95% accurate. Now, to be honest with you, this is a little bit ambiguous, okay? 95% accurate can mean a couple of different things. So I want to try and illustrate this to you in an intuitive way. Let's first of all think about that first piece of evidence, the fact that the disease affects 0.1% of the population, okay? What does 0.1% actually mean? What does 0.1% actually mean?
1 over 1,000.
Absolutely. Okay, 1 in 1,000. Okay, so what that literally means is that if I put 1,000 people in a room, you can see 1,000 people there on the screen, okay, I would expect one of these people, there he is, to have that disease. That's what 0.1% of the population means. Is that okay with everyone? Right? Okay. But I also told you this second piece of information. So if I just left it the first bit of information, so 0.1% of the population, okay, would you be happy that I said, well, what's the chance that you have the disease? You would say pretty unlikely. Yeah, because it's only 1 in 1,000. If you put 1,000 people in the room, by chance, only one of them will actually have this disease. So the chance of you having that disease, based on that first piece of information, is quite low. But then I tell you you're positive, you test positive, and the test is 95% accurate. So let's think what that actually means. What it could mean is that 5%, so if it's 95% accurate, that leaves 5% of the time where people are told they have the disease when actually they don't. Okay, so 5% means that, so 95% accurate means that 5% of people are told they have the disease even though they don't. Okay? Does that make sense to everyone? Yeah? Because it's 5%, it's wrong 5% of the time. Yeah?
And 5% equals to 50 people.
Perfect. So because we've got 1,000 people on the screen, yeah, we would expect if we tested every single one of these people that 5% of them will be told they have the disease even though they don't. And 5% of 1,000 is... So absolutely, 5% of these 1,000 people will be told they have the disease even though they don't. That means that these 50 poor souls will be told they have the disease when actually they don't. Does that make sense? So actually, if we take away all the people who haven't been told they have the disease, this is who we're left with. How many people are there on the screen? We started with 1,000. We take away the people that we know don't have the disease. We're left with 51 people. Okay, so we're left with 51 people on the screen that are told they have the disease. Now, we know that 50 of these people, in other words, the people in pink, are told they have the disease even though they don't. That's what the 95% accurate people does, okay? But this one poor blue soul sitting here, right, is the one person in that original 1,000 that actually has the disease. So really, when I say what's the probability that you have the disease, what I'm asking is, what is the probability that you're this one person in this 51 sea of people? Yeah? Now, what's 1 in 51? Well, it's approximately 2%. Does that make sense? Yeah?
In reality, when a test is not accurate 100%, so missing that 5% accuracy, does that mean that 5% are 100% like,
Yes. Absolutely.
in theory
If
affected with the
exact, not in theory infected, you're told that you have the disease even though you don't. Yeah. So actually, this is a real thing. Like they showed this thought experiment to a group of medical students, and like medical students were thinking like me. They were thinking like, oh, it's still 95% of people. Like 95% of the time, it'll be absolutely fine. There's a 95% chance that you'll actually have the disease. It's not. It's only 2%, right? Which is why, if you've ever kind of gone to the doctors or something like that, they don't just take one test. They take more than one test, yeah? And they do it multiple times because the idea is, if you only do it once, okay? If you only do it once, there's only a 2% chance that you'll actually have the disease, right?
So does that mean that the real answer is not 0.1% of the population, it's 2% of the population that would be affected?
No, it doesn't mean that. It's still this. This is still the chance that you have the disease in the entire population, 0.1%. However, if you go out and you take a test of every single person in the population and it comes back as positive, there is only a 2% chance that that person actually has the disease.
Okay.
Yeah? Which is weird, isn't it? It's completely counterintuitive, right? But I've just taught you through the logic behind it, and it makes perfect sense. This is the idea of Bayesian statistics. It's a way of updating your current beliefs based on your previous beliefs. Is that okay?